Good morning, guys. Today we're looking at surds. What are surds, and hopefully looking a little bit at simplifying surds as well. First of all, we're going to look at what is a surd. Well, hopefully you'll remember that a surd is a number that is generally under what we call a root sign or a radical sign. Now, this can get a little bit confusing because I'm going to write two different numbers here. One is a surd and one is not a surd. I wonder if you can figure out which one is a surd and which one is not a surd. Hopefully you figured out that 16 or square root of 16 or root 16 or radical 16 is not a surd. Okay, the reason for this because we can simplify the square root of 16 to be 4. Now basically what the official definition of a surd is, where I cannot, or they say basically a surd is an irrational number. Okay, so they call that an irrational number as opposed to a rational number. So what is a rational number? Well, a rational number is where you can write it as like a fraction, a over b, where both these numbers here are integers. Now hopefully you remember that an integer is simply a whole number, including 0 as well, of course, but positive and negative whole numbers. So for example, the square root of 16, which equals 4, can be written as 4 over 1. Okay, but as opposed to if you grabbed your calculator and typed in the square root of 5, you find that it won't come out to be a whole number. It comes out to be something along the lines of like 2.236, etc., etc., etc. So it keeps on going. So it's not like a nice sort of fraction like a 4 over 1. So basically a surd involves having a number with a root sign, or that's also called a radical. Okay, so you can have things like the cube root of 7. Out of those two numbers, I wonder which you would say is rational or irrational, or which is a surd or not a surd. Hopefully you can recognize that this is an irrational number or a surd as opposed to this, because the cube root of 8, if you do that in your calculator, you come to the answer of 2. So obviously that can be written as 2 over 1, so that is not a surd. So let's just get that straight. First of all, a surd is simply a number that is written with a radical sign or a root sign that can't be simplified to a nice whole number, okay, like 4 or 2 in this case. Okay, so that's very basic what a surd is. So sometimes you'll remember when we did some other work with our trigonometry, we looking at exact values. Now our values looked at things like this. Okay, remember, we did that little triangle, and we had that was 60 degrees, 30 degrees, which is good for your trigonometry revision, which we said that was a side of 2 centimeters, half of 2 made 1 centimeter, and then 2 squared, which is 4, minus 1 squared of 1 is root 3. Okay, and you might have asked to be find the value of sine 60, or the exact value. Now the exact value meant we had to leave it in surd form, because if you use your calculator, it's not going to give you an exact number. So if I found sin 60, well, at 60 it's root 3 on 2, because opposite over hypotenuse. So we left it as root 3 on 2. So the exact value would be root 3 on 2, because if I again use my calculator and did sin 60, it would give me a decimal place that we'd have to give an approximate answer, like 5.2 or something like that, to 1 decimal place, 2 decimal places. So an exact value or a surd gives you the exact value of that number without having calculated. Okay, because again, you can only give an approximation to 1 or 2 decimal places of a surd. So yeah, that's why we can't actually go ahead and use our calculator to find that, when of course we're looking for the exact values. Okay, so hopefully we can recall that a surd is simply a number that has a radical sign or a square root sign or a cube root sign above it. So what we want to look at, once we've recognized that we have a surd, is how to simplify a surd. And that's all we'll be doing in this lesson. Now, hopefully, again, you have done this before. If not, this is totally new to you. That's okay. Okay, now I'm just going to look at this question. I know this is not a surd. Okay, but how would you simplify square root of 9? Well, you probably don't need a calculator, but if you did have a calculator, you could do that. But hopefully you'd recognize that square root of 9 equals 3. So these particular numbers, rational numbers, are nice to have because we can simplify them very quickly. Obviously, if I had the square root of 5, which is a surd, we can't simplify it any further because there's nothing smaller we can make it, because obviously it doesn't go into a nice rational number like the top one does. So we can't really do anything with that simplifying part there. So, but then you come to a question like this. We might have, let's say, the square root of, let's say, 8. You go, well, okay, I can't square root 8 because I can square root 9, but I can't square root 8. So how can I simplify that? Is it possible? Is it just like the square root of 5? But in this case, it is not the same as square root of 5 because this can be simplified. Again, if you've done this before, you might remember it. If not, what we want to do, we want to see if we can break down the square root of 8 into its factors, or two factors. So let's think, what two numbers multiply to give 8? Well, you can have 8 and 1, but as we know, often 8 and 1 doesn't help us. But what we can do, we could do 4 times 2, because 4 times 2 is 8. Now, the reason why we do this, and there will be a bit of a trend to it that you'll see, that this, in fact, is exactly the same as saying square root of 4 times the square root of 2. Now, again, you might be thinking, why are we doing that? However, you might have recognized something. You might have recognized that the square root of 4 is not a surd. It's not an irrational number because we can find the square root of 4. So what is the square root of 4? The square root of 4 is 2. So now we've got 2 times root 2. I'm going to write it like that because it's like having a 2a. You don't have to, you can just put them together. Okay, it's still there. Is an invisible little times in there, but we don't have to put it there. And actually what we've now done, we've now simplified the surd root 8 into 2 root 2. Okay, so a good idea if you have to simplify a surd and you're given a question where you need to simplify a surd, let's see if we can break the surd down into numbers that would give us, I guess a good way of putting it would be a perfect square, like 4, because it's 2 squared, or 9 is 3 squared. Let's have a look at this one. We're going to do, let's say, the square root of 18. Now again, if you put that into your calculator, it's not going to come up to be a nice whole number. So it is in fact a surd. And it won't let you put it as a fraction. So again, it's an irrational number. But let's see if we can break down the square root of 18 into some combinations. Now, I could do 6 and 3 because 6 times 3 is 18, right? That's correct. But are you able to square root either of those two numbers? No. So that's not going to work. But you may have said, what about 9 times 2? Because you've hopefully recognized that the square root of 9 is 3. And so we're simply just left with 3 root 2. Now some people like to write that extra step out by saying the square root of 9 times the square root of 2. If you are that kind of person and you want to write that extra step out, then go for it, okay? There's no harm in doing that. But if you think you know straight away when you've got the 9 times 2 underneath the radical sign, then you can just put the 3 at the front, okay? And that means 3 times root 2, which would give you, if you want to check on your calculator, it will give you the exact same answer as root 18, or radical 18. Okay, so that's what we look at simplifying. So, you know, my best suggestion when you're doing this kind of questions, look for your perfect square numbers. So when I'm talking about my perfect square numbers, I'm talking about things like 1 squared is 1, which doesn't often help you. 2 squared is 4, so that's a perfect square. 3 squared is 9, perfect square. 4 squared is 16, perfect square. 5 squared is 25, perfect square. And generally those ones will give it to you, like we'll give you most of the answers, but you can still go up to like 6 squared, 7 squared, 8 squared, 9 squared, but generally most of your numbers will include these ones here, not too many more. So let's have a look at another example. Let's say the square root of 50. Now again, we could do 5 times 10. Yes, we could do that. You know, we could do a lot of different things. But 5 times 10 doesn't include any of these little numbers here. And that's the whole reason of breaking it down, because we want to have a perfect square which we can square root. So what times in here can we times together to make 50? Well, you might recognize 25 times 2 makes 50. So the square root of 25 is 5, and we've got root 2 left. So it's not that difficult, is it? Okay, once you've found or you located and one of your perfect squares that you can break it down to, it's quite a nice little easy thing to sort of do. Another popular one is square root of 20. Okay, so square root of 20, hopefully, let's have a look. Well, 10 and 2 is not going to work, 20 and 1 is not going to work, but you may have recognized 4 and 5 again, because see the 4? Okay, that's one of our perfect squares. So the square root of 4 makes 2, so we make 2 root 5. Again, if you wanted to put square root of 4 times the square root of 5 into that extra step there, you're more than welcome to do that. Okay, and we get 2 root 5. Look, that's it. I hope you found this useful. Please, please, please practice this stuff. Go on to the next couple of lessons that I've got set out for you, because it's not actually that challenging. It's pretty fun. Have a good day.